know why it's all blurry. All right, young people. I think we're good to go now. And with all the mistakes, we're gonna keep it going. So anyway, this is a eighth grade math lesson about solving equations with variables on both sides. But before we get there, we're just gonna do a brief refresher about rational coefficients, right? So what you're going to see with the variables on both sides, especially when we get to the multi-step equations, is you're going to see these fractions here, right? That's what they mean by rational. You see the ratio in front, and the coefficient is in front of the variable. So we gotta clear the fraction. Essentially, is what we have to do to solve for x. So just remember, when you're solving equations, you want to do the inverse operation. So this is multiplying by 1/8. And so we want to do the opposite of multiplying by 1/8, right? Which is essentially dividing by 1/8. But remember, when we divide fractions, that means we multiply by the reciprocal, by the reciprocal. So reciprocal means you flip, right? You flip the denominator and the numerator. So the reciprocal of 1/8 is 8/1. So essentially, this is what we're doing. We're doing 8/1 times 1/8 x. And then we're going to do that on the other side as well, right? Because what you do on one side, you got to do to the other. We already know 8/1 times 1/8, that cancel, right? Because that equals 1, which is x by itself, which is 1x. So on the left-hand side, all we're going to have is x. Because 8 times 1, 1 times 8 is 8/8. It kind of reduces to 1. Over here, remember when you're multiplying fractions, right? You multiply straight across. So 5 times 8 is 40. 1 times 1 is 1. So your answer is 40. All right, you can check it. 1/8 of 40, right? So if you divide 40 by 8, you get 5. That's how you know you're good. So this is a skill you have to keep in mind, especially when we get to those multi-step equations. You got to remember to multiply by the reciprocal. All right. So for another example, we got 2/9 W equals 24. So we got to multiply by the reciprocal. So the reciprocal of 2/9 is 9/2. So you do 9/2 times 2/9 W equals 24. It's just a habit of mine to put it over 1 so I don't forget, times 9/2. So we're going to run into the same situation here. This is why we do it, because we want to get the 1W. We want to get W by itself. Okay. Remember, when you're multiplying fractions, you could make the work a little bit easier for you and look diagonally and vertically if there's anything you can reduce. So I can reduce this right here. 2 divided by 2 is 1. 24 divided by 2 is 12. 12 times 9, what is that, 84? Is that 84? No, 12 times 7 is 84. 12 times 9 is 108. Yeah. And so we're going to get W is equal to 108. Because again, when you're multiplying fractions, you multiply straight across and you get 108/1, which is what we have over here. Okay. So again, when you have the rational coefficient, remember to multiply by the reciprocal. By the reciprocal. Okay. So this is just a refresher as to how to do those kind of problems. Okay. Since I'm gonna put this in Edpuzzle, I need y'all to handle number 3 and 4. Those will be your those will be your questions that I need you to answer on Edpuzzle. Number 3 and number 4. 3/7 times k is equal to 12 over 35. And then 8/9 p equals 12/18. Remember, reduce the fractions up front to make your work a lot easier. You don't have to. If you don't reduce up front, you're going to have to reduce at the back end. So just keep that in mind. Now let's get to the good stuff. Okay. So this is going to be what you need to do on your homework assignment. You're going to have to do solving equations with variables on both sides. This I'm gonna put into Schoology. So you just go ahead and work it out in Schoology so you get the automatic feedback. But let's talk about a few of these so you get the hang of it and so you understand the concept of solving variables on each side. And this will come in handy, especially when we get to systems, because you need to convert from standard form into slope intercept. It's the same principle. It's kind of happening here. Okay, here we go. So number 1, a good kind of a good premise is you want to move the smaller coefficient, right? Move the smaller variable to the side with the bigger one. It makes your work a lot easier when you do it like that. So you see I got W's on both sides. I'm going to move my 3W over here where my 4W is. Again, because it just makes the work a lot easier. So how do you move it? You do the opposite or the inverse operation of whatever it is. So the 3W is positive. So what we're going to do is we're going to subtract 3W on the left, and we're going to subtract 3W on the right here. Okay, again, our goal is to get the variables all on one side and the constants on another. So when we get rid of the 3W, all I'm going to have is 6 is equal to, and 4 minus 3 is 1. Remember, in algebra, we don't write 1W, it's just W. Okay, so again, let's talk about what I did. When you have the equation here, what you want to do is look at your variables here. Look at whatever one is smaller, right? So 3 is smaller than 4. We know that. So we want to move the 3W. We want to move it over here. And so how you manipulate variables is you do the opposite operation of whatever it is. So I subtracted 3W. I didn't add it. If I would add 3W, I get 6W. If I add 3W, I get 7W. I didn't isolate my variables. So that's why you got to do the opposite. So when you subtract 3W here, subtract 3W here, you get 1W, and you bring down your 6. All right, you don't do anything else. This is what you want. You want to solve for the variable, so you're good. Let's move on. Number 2. Number 2 is the same situation. We got 1A and a 6A. I'm sorry, 7A. 1A and a 7A. Right, so look at your variables, look at where they're at. All right, bet. Now I want to move my 1A. I want to move the 1A over here to the side with the 7A. You don't have to do this. It just makes the work a lot easier for you. So when you subtract the 1A, you get 18 is equal to 6A. And then, you divide by 6. So A is equal to 3. Okay, so again, what did I do? I moved the smaller variable to the side of the bigger one, and I did that by doing the inverse operation. 7A minus 1A, 6A, boom. And I bring down my 18. I still don't have, I didn't solve for 1. Right now I got 6A, and I got to solve for 1A. That's how you know you're done, when you have 1, right? When you just have the variable by, you just have 1. So a divided by 6, I got a one-step equation, divide, and I get a is equal to 3. You can check it, right? So you do 3 plus 18 is 21, and 7 times 3, 21. It works out, you're good to go. Okay. Let's kind of do one more of these easy peasy ones. Let's move here to number 3. Number 3, same thing. Look at your variables, right? I got a 5C and an 8C. 5C is smaller. So I want to move my 5C over here to the 8C. So how do I do that? You do the opposite. So right now it's a positive 5C. So to get rid of it, I do a minus 5C. Or you can think about it as adding a negative, same thing. I bring down my constant, 21. 8C minus 5C is 3C. Bam. You see how that works out? That's why you want to move the smaller variable to the larger side, to the larger variable, because when you get to the work, it makes the work a lot easier for you, right? Divide by 3, C is equal to 7. Okay, and then you can check it. You can check it if you want. 5 times 7 is 35, and 35 plus 21 is 56. And 8 times 7, 56. It all works out. Okay. These are some of the easier ones. So, I don't anticipate you, running into problems here. Let's get into the juicy one. Where is Mr. Juicy? Juicy, 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 juicy. Okay. I'm looking at number 19 here. I'm looking at number 19. Yeah, let's look at 18 and 19. 18, you're kind of dealing with the same principle, right? You want to move the smaller variable, right? You got a negative 2a and a positive 6a. Move the smaller variable to the larger side, right? Move the smaller variable to the larger side. So the opposite of negative 2a is positive 2a. So you're going to add your 2a there, and you're going to add your 2a there. Remember, you don't add 2a to negative 9. Those are unlike terms. We don't do stuff like that because we know better than that. All right, you bring down your negative 9. 6a plus 2a is 8a. And you bring down Mr. 15. So I'm glad I chose this one. Here, I still don't have 8a by itself. That's my goal. I want to get the variables all isolated and get my constants over on one side. So when you have a constant still attached with the variable, you got to get rid of that. So now I got a plus 15. So I do the opposite and I subtract 15. I subtract 15 from both sides. So let me rewrite this up here. I have negative 9 equals 8a plus 15. So again, you want to get the variable all by itself. And right now it has a partner. We want him to be, ride solo. So he don't want this partner right now. Let's get rid of his partner, right? So let's get rid of the 15. And how do you get rid of it? You do the opposite. So I'm going to subtract 15 here. And I subtract 15 here. Bring down Mr. 8a. Remember, plus 15 minus 15, they cancel. Negative 9 minus 15, or negative 9 plus negative 15. Right? Negative 9 plus negative 15. Negative 9 plus negative 15 equals negative 24. Right? Remember our integer rules? right? When you're adding, yeah, when you're subtracting, you add the additive inverse, or you add the opposite, right? So adding, ugh, we add the opposite here. So then we get negative 24 divided by 8, negative 3 is equal to A. Okay, now let's check it just to be on the safe side. 6 times negative 3 is negative 18, and negative 18 plus 15 is negative 3. So I get negative 3 over here. Let's bust it over here. Negative 2 times negative 3 is 6. It's 6. And 6 minus 9, or 6 plus negative 9, is also negative 3. Everything checks out. We good to go. Okay. So again, we're still working with the same premise. Take the smaller coefficient, move it on the side with the bigger one, right? Take the smaller variable, my negative 2a. I want to manipulate the variables first. You don't have to do it that way, right? You could manipulate the constants first. You could do that. You could do that. And you know what? You work with the same principle, right? Move the smaller constant to the side of the bigger one. You could rock with it like that. Right? We can approach this animal a few different ways, but the bottom line is we need to have all the variables on one side and all the constants on another. Okay. So my strategy, I dealt with the variable first, which is fine. So I added 2a because it starts off with being negative. That's why I add 2a. When I add negative 2a plus 2a, boom, cancel. I get 0. And that's when I bring down Mr. Negative 9. Okay, but this constant is by himself. So my left side is good. Then I go over here. When I combine my like terms, 6 and 2a, I get 8a. And I bring down Mr. Plus 15. Remember, I want to get 8a by itself. I want to isolate it. So I got to subtract 15, which is what I did over here. When I subtract 15, plus 15 minus 15 cancel. So I bring down Mr. 8a. And then negative 9 minus 15 turns into negative 24. Right? Negative 9 plus negative 15 is negative 24. Divide by 8, my answer is negative 3, because a negative divided by positive is negative, right? When you're multiplying or dividing integers, if they're the same sign, positive, different sign, negative. So we got negative 3 here. Okay. One more, and then I'm gonna, bless y'all with this homework. Number 19, same principle as number 18, really. So I don't know why it stood out to me. Yeah, the rest of these, we kind of went easy on you here. Number 19. So again, work with your variables first. We got a negative 3k and a positive 3k, right? So move the negative 3k because it's smaller. Move the smaller coefficient to the big boy side, right? You want to stomp him with the big dogs, right? You want to move him with the big dog. So we're gonna add 3k because that's the opposite of the minus 3k here. We're gonna add 3k. Okay, minus 3k plus 3k, they cancel because that equals 0. I bring down my constant, Mr. 8. So on my left side, I got 8 equals 3k plus 3k, 6k. And I bring down my plus 2. Okay, now just like over here, I want to get rid of the plus 2 because I want to have 6K by itself. I want to get rid of the plus 2. I want to isolate my variable. So subtract 2 from both sides. Okay, I'm going to move this up here. 8 equals 6K plus 2. All right. So again, I do not want this 6K plus 2 because it's ugly. The variable needs to be alone. Okay. So get rid of the plus 2, subtract, and subtract. You don't want to subtract 2 from the 6K, remember, because they are unlike terms. You want to subtract a constant from the constant. So my plus 2 minus 2, they equals 0. Awesome. Bring down Mr. 6K. 8 minus 2 is 6. Boom, boom, boom. Now I'm in a one-step equation. I got my variable by itself, constant by myself. Now I solve. I don't leave it like this because I don't want 6K. You know you're finished when you have 1, when the coefficient is 1. So I got to divide. And 1 is equal to K. Okay. Now for good measure, plug it in. Right? Check it. If K is equal to 1. So 3 times 1 is 3. 3 plus 2, 5. Right? 3 times 1, 3. 3 plus 2, 5. All right, cool. Here we go. Order of operations, I do my 3 times 1 first. So 3 times 1 is 3. 8 minus 3, 5. Splat out. Good to go. Okay. So, I went through plenty of examples here. I know you all can handle the rest. So make sure you check Schoology. You'll see the assignment, solve variables on each side, and y'all can handle this. I believe in you. If you got questions.